All right, so what I wanted to have a look at is a system of simultaneous equations where you've got these extra parameters. So you can see we've got these two equations, x plus 5y equals 4 and 2x plus by equals c. But what we're saying is we've got these extra parameters in here, b and c. And then we've got three different situations. We've either got a unique solution, we've got infinite number of solutions, or we've got no solutions. Now remember, a unique solution is when the lines don't have the same gradient, so they intersect somewhere. An infinite number of solutions is that the lines are the same line. So they're literally just on top of each other. So the gradients are the same and the y-intercepts are the same. And then no solutions is the lines are parallel, but the y-intercepts are different. So what we need to do with this type of question is we need to find out what B and C are in each of these situations. You can see as I change the value of B and C, different things happen to the red line because the red line is the only one that has parameters in it, right? The green line is just a line that's fixed. Okay, so let's have a think how we can approach this. So the first thing we're going to say is we need to find out what the gradient of the green line is. So just subtracting x from both sides, we get 5y equals negative x plus 4. And then dividing by 5, so we get negative x on 5 plus 4 on 5. And then the reason we did that is to get into, that's in the form y equals mx plus c. And then we can say that the gradient is negative 1/5. Okay. Yeah, the next thing we can do is think about the gradient of the red line. So the red line, if we rearrange a little bit, we take negative 2x, we take away 2x from both sides, divide by b. We get y equals negative 2x on b plus c on b. Okay, so the gradient of that is negative 2 on b, just the coefficient of x, right? So let's have a think. So if I change b, apparently that's going to change the gradient of the red line. And that's right, because the gradient of the red line only depends on b. It doesn't depend on c. If I change c, clearly doesn't change the gradient of the red line. So just sort of interpreting what's going on here. Now, if we've got a unique solution, the only requirement for a unique solution is that the gradients aren't the same. As soon as the lines don't have the same gradient, they're going to intercept at some point. So for example, this is a perfect example. At the moment, they don't have the same gradient. So you'll get a unique solution. So basically all we need to say for a unique solution is that, negative 1/5 is not equal to negative 2 on B. Okay, solving that for B, solving what B isn't equal to is you'll get B is not equal to 10. Just solving it like you normally would, but then saying that it's not equal to whatever your answer is. So in this case, not equal to 10. Now this answer is okay depending on what you've learnt in mathematics, but a better answer is to say what B is equal to, when the way we do that is using set notation. So you can define it in terms of what it isn't, but you can also define it in terms of what it is. So a better way to write it would be to say that B is an element of any number, all real numbers, not including the number 10. Is probably the better way to write it. It's the more sophisticated way. Okay, so as long as B is not 10, they're going to intersect, and you can sort of see that. Something interesting is happening when B is 10, though. And let's have a think about that. So if there's an infinite number of solutions, we know that the lines are the same line. So if they're going to be the same line, they're going to have the same gradient. And we know that if B is equal to 10, they're going to have the same gradient. Okay, and just the opposite of this. In this case, we wanted them to not have the same gradient. Now we want them to have the same gradient. So B is equal to 10. So it's going to give us an infinite number of solutions. Now we just need to work out what the y-intercept is. So we know that 4/5, the green line, has to equal C on B, but B is 10. So we're going to get 4/5 equals C on B, but B is 10, so that's C on 10. So C on 10 equals 4/5, multiply 10 to both sides, we get C equals 8, is when we have infinitely many solutions. So B is 10 and C is 8. Let's do that. There you go. And you can see when C is 8, those lines are indistinguishable. They are the same line. Okay. And then, so the last part shouldn't be too tricky now. We just need to say when there's no solutions. Well, hopefully you can see no solutions is going to be anywhere where B isn't 8. Anything other than 8, we're going to get no solutions. So how we could write that is as follows. We could just say B is 10 and C is not equal to 8. Again, a better way to write that is with set notation, and we would say that C needs to be an element of any real number. So it's an element of real numbers, but we can't include just the number 8. Okay, so hopefully that clarifies those types of questions. A very common assessment type question, because yeah, it builds in these other parameters that you need to really think about. And I think hopefully the visualization of the graphs helps with that a little bit as well. So definitely an important one to wrap your head around. All right, good luck.